fasting for anyone that doing fasting in Ramadan, and welcome again once again to the Global Azure Bootcamp 2020 virtual in Singapore. It's a lovely day, it's a little bit rainy, but it's a good time for us to learn something about Cloud Native, right? Okay, okay. Let me just get the control, and I am going to use a laser pointer. Okay, so some of us already using cloud, but some of us still kind of like don't quite understand the difference between the normal using the cloud or using a cloud native application. And everybody is now is have some ideas about what is cloud native application. So what we are going to talk about in this session is about what is the cloud native definition itself, and then I am going to explain a little bit about application architecture patterns for the cloud native, and then I am going to talk about Dapper, distributed application runtime. This is probably some of us just heard about this. It's something new, and then we going to do some demo as usual. Okay, so let's talk about cloud native. If you look at the IDC, you see the prediction, first prediction in 2022, the top 4 clouds, include of course Azure, is going to talk about cloud native. So we can see from here, multi-cloud and cloud native approach. This is in 2022. And then in prediction number 2 in 2021, which is next year, 70% new enterprise application will be developed cloud native. So if you're still not doing cloud native, you need to jump to the water right now. So this is the time for you to learn, to understand what is cloud native. I'm still learning as well, but this is a good thing. We use this in our own project because I'm working at NUS. So this is something that you want to have a look. You're going to love it. Okay, so what is cloud native definition? When we use cloud computing, this is what we see, right? Compute, and then storages, containers, security, serverless, app services, databases, and DevOps, right? And the other 1,000 products that are available inside Azure, for example. So this is a lot of this thing that can be part of cloud native, but some of them you can only just use a casual cloud computing, no cloud native at all. Okay, so but what are clients and customer expectations when you say that, oh, we're going to move to the cloud? That is the problem, right? So we need to know that most of the client or the customers, they ask for quality, which is the value by the client and the customer. So when they go say they don't need to move to cloud, they're expecting something that's high quality software. And then scalability. So they don't want to have some kind of like when they move to the cloud, and there's a peak season, for example, and then they have to go to the server and they have to do something with the server. That's something they don't want to do. So they want scalability. And the third one is availability. So they don't want the server that they have on the cloud is suddenly is not available, or 500 server not found, server error, or something like that. And then security, this is the most important as well. So they are expecting that the security is very high. And then modifiable, they want it to be, if I want to change something now, I can change it and then can be deployed as soon as possible. So this is what the client expecting with the cloud native. And then of course the last one is maintainable. So this one is maintainable, is something that is suddenly come out within the last few, after the cloud era. So previously maintainable, they know that you need to have a request, go to the software vendor and then do something, and then so it's going to take time. But now they say that, hey, if I want to have a software, maintainable. So meaning that we can do orchestration inside the software. So the cloud native is not about how. The cloud native is about how, not about where and what we use. For example, well, we use this, we use that. No, it's not about that. It's about how we use it. That is the most important in the cloud native. So according to the CNCF Cloud Native Definition version 1, so the cloud native is a technologies empower organization to build and run scalable applications in modern dynamics environment such as public, private, and hybrid cloud. Interesting, right? If you see this is public, private, and this hybrid cloud. So it's not your just simple data center. It's even is in your on-premise, but it's you can join in with the cloud, but it's like a cloud. In Azure, they have that, so call it Azure Arc, for example. But we're not going to talk about that. So what is the one that is not cloud native, but you are using cloud, right? I'll give you some example. For example, my monolithic web app is running on cloud. No, you cannot consider it as cloud native. You're just using the cloud to run your app, but it's not cloud native. And then my database is now in cloud. Yes, so that is also not cloud native, but we are using cloud, which is still good, still fine, because you can do some kind of like configuration, but it's still not cloud native. And then my API is fully running in cloud. Oh yes, but how you run it? For example, if it is only one server VM, for example, that is not cloud native. And the other one, the last one is, for example, is my app running? My app is running on VM or app service in cloud. That is also can be considered in cloud, but it's not cloud native at all. At full, not you can say that I still have cloud native in it, but not full of them. So cloud native is actually applies to more than just the apps. It's not about you just deploy in the cloud. Sorry. So the cloud native infrastructure is one of them. So the infrastructure should be able to be scaled, should be able to scale in or scale up, scale out. That is something that you need to consider when you're talking about cloud native infrastructure. So this will lead to how we develop the software itself. So by understanding this, for example, like the cloud native data, the data to be resilient, on demand data tier, for example. So the data is always on, always available, and can be accessed easily and fast, low latency, for example. That is something that when we design the software for cloud native. And then the cloud native security, of course, you can use Azure AD, OpenID, whatever, the Azure Key Vault, Azure Sentinel. So this is something that is part of the cloud native. And then, of course, the cloud native integration. And this one, I will introduce Dapper. Some of you probably already know Dapper, but if you don't know what is Dapper, I will introduce this Dapper. So this is something that is also new, the cloud native integration. So in application architecture patterns, usually when you talk about cloud native, is usually microservice architecture. But everybody, when we talk microservice, everybody try to run because, oh, okay, this will be more difficult. I need to manage this. I need to have this. Not true actually. So number one is you have to make it modular, all of the components. That's it. When we do coding, when we create a project, we need to have modularity. So everything should be decoupling, and then you have to have boundaries. This is the concept like domain-driven design. So you have to have a bounded context. So you don't mix one system or one function with each other, and that is not cloud native. That will become monolithic. But if you separate everything in a different domain, for example, you're talking about orders, and then you're talking about checkout, for example. That is a different orders. Orders is just a list, and the other one is checkout is when you go to the payment, for example. And then surgical scaling. and not the entire machine scaling. So for example, if you have a lot of VM and then you have load balancing, you're from 2 VM, you want to scale up to 100, yeah, we can say that it's cloud native, but that is not surgical scaling, meaning that you add more machine and it's going to cost you a lot of money. And then after that, there's a CI/CD. You have to consider CI/CD when you develop the software. I myself feel that not feel experience you have to use CI/CD because it is almost like if there's too many microservice, for example, too many API, that is a bit difficult to control. And then the contract driven test. So this one is the test itself is actually must be real and must be implemented in the contract between the customers, the product owner, and the developer. So you have to run the test exactly as it is. And then organize around teams. You can use Scrum, Agile when you develop this microservice architecture. So this is the component that is a part of the pattern that when you create an application architecture for cloud native using microservice, this is part of the components. And then for the application itself, I favor event sourcing and CQRS pattern. So if you don't know what is CQRS, CQRS is a comment query and responsibility segregation. It is the different concept with the CRUD. CRUD is the create, read, update, delete database, for example. So CQRS is different. Is another pattern. Is a event sourcing. Is a domain. Is an event driven kind of thing. So this is something that you need to consider when you want to create microservice. I tell you, don't try to use CRUD. It's going to be like difficult to control, or you cannot. It's difficult to manage. But CQRS is easy when you design microservice. And then this one is make sure no hard-coded configuration. And then you have to have messaging. For example, you can use RabbitMQ and Service Bus, Kafka, or any other. If you use Java, you can Springboard or this kind of thing lah. And then API gateway. I usually use Azure API management. These are top choice of easy to manage. The good thing is API management. If you have a hybrid, you can join this your on-premise server and your in cloud server by using virtual network, and it's in private. Even your API management is private, so no one can access. Because currently, if you use Azure and use the Azure API management, they are all public. But if you can make it inside a VNet and it's running really, really private within your enterprise. And then service discovery. This is very nightmare. When you develop microservice, how do we find the service? Sometimes when we add something or we change something, the service changes. How we discover this? So this is part of the difficulties when we develop microservice, but it's something that we need to consider. We need to prepare. And then circuit breaker. So circuit breaker is something that you can cut everything off if something wrong. So you can cut the entire system just to break the system running. And then token-based security, for example, you can use OpenID Connect, you can use Azure B2C, for example, or you can use Azure AD as well, as long as using a token-based security, but not using the OS infrastructure identity, for example, like Windows identity or Linux, for example, or any other OS-based security. And then scalable database on demand per microservice. This is something that a lot of developer sometimes is asking me, do we have to have one database per microservice? The answer is yes. But how is the database? It's not like enterprise database like SQL Server you have to put inside. No, it's not like that. So later we can discuss about that. And then we have to use the intelligent caching to improve the resilience. Caching is number one, especially when you use CQRS and using event sourcing. Let the event go, because the event is immutable. When the event comes, you cannot do anything, you cannot change, and it's already written. If you want to change the state of the data, all you have to do, you have to have another event to change that. That is CQRS, and event sourcing is all about. And then the other part that in the microservice you have to consider application the delivery pattern, which is the one that I said to you. When we do microservice, we have to use CI/CD. So in this case, use Azure DevOps. Version control is a must. You can you use Git. Yeah, now it's already Git. Git is the best. So use Git, and then only build from master branch, because sometimes I see developer, they build from other branch, their own branch, and then they try to run manually. That is not the right way. So it must be automatically when they push, trigger, commit, or push the CI, it will build the application. And then try to use containers for deployment. Unless you want to deploy for a certain machine, then it's fine. But for microservice, it's better to use containers. Unit tests, this is a must. You have to have our unit tests running inside the DevOps. There is an option there in Azure DevOps that you can enable unit tests, or any test like BDD, the one that Ben just now showed to you. That is something that you can consider when you're creating microservice. And then test in production like environments. This is the integration. This will be related to Dapper later. I will share with you. And then the artifact repositories. So in Azure DevOps, if you look at the menu, there's an artifact. That is where you can put your microservice package, for example. So this is something that is a pattern for application delivery in Azure in microservice for cloud native application. Now, just now we see a lot of things, right, in the architectural and patterns for the cloud native. Not a lot of people like to play around orchestration, this kind of thing, because they just want to easy to access one machine and then they can do with the code. The problem is because sometimes they have a multi or they have a different framework when they use the application. This is why Microsoft open source create Dapper. So this is a distributed application to help easy to develop microservice. So this is an open source by Microsoft, and you can contribute. So what is Dapper? So the state of enterprise developers is being asked to develop a resilient, scalable microservice-based app that interact with service is hard. So to make it easy is to have something in the middle that can help make this resilient and scalable microservice application easy to be developed. And then increasingly polyglot. I use C#, someone use Java, someone use Go, someone use Python and Node.js. How are we going to make this into one system in the microservice? Because, for example, if I set up only for ASP.NET Core and the other one comes from Java and said, what is that? I don't understand. And the one that's from Node.js, I don't understand this. So that is increasingly polyglot, because now most software developer, they have a different language in different area as well. So some of the enterprise also, they want to leverage the existing code. They just want to copy paste. For example, you already have Python. You don't want to change to other language. Why? Why you have to change to C#? Or why you have to change to C++, for example? Just use that code. So this is become a bit difficult when we want to do microservice. And then how about functions, workflows, and actors? This is something that is very important when you want to create microservice, especially functions. For example, it's something that when you execute, and then that's it. The execution is only for that function as well. And then the other one is Sega. Sega is a workflow. If you look at the domain-driven development design, there's a Sagas, S-A-G-A-S, Sagas or Segas. So this is something like a workflow for not similar the one that is like Microsoft workflow. It's not like that. So it's a little bit in development workflow. And then actors. So actors is something that I cannot, because I try to measure my time in here. I cannot talk about actors due to time. But later maybe I can share more in detail. So what is holding microservice development back? It's hard to incrementally migrate from existing code. That is the reason. Programming model runtimes have narrow language, and then runtimes only target specific infrastructure. Most of the time, this is the one of the priority issue. Second is this one, and then probably the third one is this. So this become difficult. They want to use cloud native, but it's so difficult. That is Dapper come into the picture. So what is the goal of Dapper? Simple. Best practice, building blocks, modular. Everything is modular. Any language or framework, polyglot, community-driven, vendor neutral. So this one can be the one that is open source framework or is a non-open source. So, you can use anything. And then adopt standard, consistent portability or open APIs, platform agnostic, the cloud. You can use Azure, you can use any other cloud vendor, extensible and pluggable components. So that is the goal of Dapper. So Dapper is not like Mesh. If you know Mesh, is not like Mesh. It's a little bit different. So the application type is, for example, is a service that is stateless, stateful, long-running, short-lived function like, for example, that can be used, which is very good. And then increasingly, apps are polyglot, written in different language. So now, once you move to the cloud native area, you don't have to worry about, oh, I have to hire this developer because he only knows this. Oh, I have to. No, doesn't matter. If they say, I know JavaScript, no JS, take it. I know C Sharp, take it. I know Python, take it. As long as you can create your apps beautifully and run in high quality, take it. So this is the last part, the microservice building blocks. They have this function, service to service invocation, state management, pub and sub, resource binding, actors, distributed tracing like diagnostic, for example, and secrets. So this is the components of Dapper. In detail, you can see from the Dapper IO. Here is the building blocks, and then you can see that this you can use HTTP inside. They use HTTP API or gRPC API, and this is the any code framework. You can use Go, Node.js, Python, .NET, Java, C++, anything. And this is, I think, is going to be more than just this. Maybe they are going to add, like, I don't know, any other language, maybe PHP or something. And then this is the framework for this. The building blocks is the standard API access for gRPC or HTTP is just like this. So it's just normal. This is the Dapper URL. So if your microservice is deployed inside a Kubernetes, for example, usually each of them has its own URL and its own port. Headache, right? How many ports are you going to handle? But in here, in Dapper, you only have one. Only one. And this one is like API management at the end, but it's more than that. And then you can run it as local or sidecar library, or for example, load it for each time you want to use it. Just imagine that this is something that's very good in microservice. The good thing is, for example, using Dapper is you need to orchestrate as much as you can when you build the software. So for service invocation, I'm not going to talk much about this, but for this front end, and then usually front end, you talk directly to the cloud, right? Using web API inside the Kubernetes. But now go to the Dapper first. Dapper talk to this, because this is this one item is one runtime. That's why it's called a distributed runtime. So this is one runtime. This is one runtime. So this card this front end run on top of Dapper. So it's kind of like it's not virtual, but it's run a process run on top of Dapper. So when you send something, you send to Dapper. Dapper inside they have some kind of like a bus. They will talk to the other Dapper, and then they will send to this. Because this is there is no logic in here, so it's the process is seamless and it's quite fast. The latency is very good. And then they have this state management. If you have microservice, you have so many API, you don't want to handle the state. Trust me, you don't want to handle state. Otherwise, you have to spin some kind of like a special app just to maintain a state, right? So you don't want to do that. But with Dapper, all you have to do, your app run on top of Dapper, and you be able to handle the state management inside. And then you can use what? You can use DynamoDB. You can use Cosmos DB, which is my option. Use Redis, also my second option. Or you can use Cassandra and others. Okay, so this is something that you want to have a look, which is very powerful. Once you use Dapper, you don't have to think about state management anymore. Just use it. It's like a session state. And even, for example, the Kubernetes spin another container, 2 or 3, the session will be the same because they maintain like that. Later, I will show you in the demo. And this is what happened when we use the state management. By the way, before I continue, when you use Dapper, you don't have to use all. You can even only choose one. For example, you just want to service invocation, can. You just want to use state management, also can. Or you want to use all of them, can. Okay. This is the one that is also very useful when you do pops up, especially when you do messaging. I think any one of you who use you do messaging in software, you know what I'm talking about lah. It's headache sometimes. So using Dapper, everything is become easy. Pops up, yep, that's it. You can use Redis as the cache, as the middleman, cache, and then you just publish everything. Redis will handle it, store it, and then Dapper will subscribe it and then send it whatever the process is all about. So pops up using Dapper is a you're going to love it. Resource triggers also. For example, you have a Redis event hubs using Kafka or SQS, and then you want to send the Dapper will use a get post. This one Dapper talk directly to this system, and then this app just talk to Dapper. You just imagine. So you don't have to learn Kafka. You don't have to learn SQS. You don't have to learn event hub. No, just use a normal API, web API or gRPC link from your app to the Dapper. So it's easy to communicate. Resource binding, okay. Also the same thing. Here you want to talk to what? Twilio, Kafka, Cosmos DB, let it be. All you have to do just send to Dapper. Dapper will handle everything for you. So it's kind of like you see this head. I think it's a butler or some kind of like a puppet. Not a puppet, is a butler. Yeah, it's a butler. It's like a Batman butler, probably. And then distributed tracing, for example, for diagnostic. This one, when the application is running, Dapper can spit out any statistics for you to capture, trace, and many more. Okay. You can even send to Azure Insight, for example, App Insight in Azure Monitor, and Sentinel, everything, and you can do it using the distributed tracing. And secret, the last one. So for secret, also the same. Just talk to Dapper. Dapper will take care of this. You just change whatever you want. You want to change this. You want to change this. You want to change this. You want to just change. No problem. Dapper will talk to it, and you can just communicate. So because in the cloud native, you probably have something in different cloud. Okay, for example, my main application is inside Azure, but there is something that is the other developer already create inside another cloud. So how are you going to do this? So the easiest way is use Dapper lah. to communicate. So yeah, building application is never been easy, especially for microservice using Dapper. Of course, Microsoft Azure, AWS, Google Cloud, Alibaba Cloud, Surface Fabric, Kubernetes, hybrid. Okay, and this one I don't know what this logo is about. So it's easy for us now to use to create microservice application. Do not hesitate if you have some idea you want to move your application to become cloud native. Do not hesitate to do it, because now if you don't want to learn everything from scratch, for example, you don't want to use raw Kubernetes or raw Docker, no problem. You can use Dapper. Dapper will help you communicate between each of the components in different mode, in multi-platform, in multi-cloud, and this is the way to go, in my opinion. And the SDK is currently is 1, 2, 3, 4, 5, 6, as far as I remember. Maybe they will add soon, I don't know. But someone, if you have some idea, you can add more SDK just to help the community. Okay, so this is one of them. For example, even the server-side Blazor, Spring Boot for Java, Logic Apps, Azure Function, ASP.NET Core, or virtual actors also can. Who use Dapper? Currently is new, but you can see from the newsletter. So this one is become like some kind of like a mainstream for creating microservice. It's become adaptation in other cloud as well to use Dapper. Okay, because it's open source and it's a bit powerful. Not a bit, it's very powerful, and a bit heavy, but it's not very heavy. Like, it's very small size, and it's only a runtime. Just remember, it's only runtime. Okay, so let's do my demo. I am going to do some simple demo by opening my Visual Studio Code. So in here we have a distributed calculator. So for example, if you are very geek a person, you want to have a calculator that have a C#, Go, Node, and Python in it. Okay, it's let's say it's a high fidelity kind of calculator. So in C#, it's simple. It's only handling subtraction. Nothing much in here. So it's only handling subtraction. See, minus. That's it. And then for Go, it's only handling this one is handling addition. Where's the addition? This one, the code is not for me, so I just want to try. Here it is. Okay, addition. So Node as well. For example, this one is division. You see this? Divide. And then Python. So Python is only for multiplication. Wow. This is a super calculator lah. So let's do something about it. Let's see what we have. Currently, I already run. So if you want to see Docker using Visual Studio Code, you can actually install the extension and just click this, and you should be able to see this. You see, this is the Dapper IO running, and this is the Dapper samples, and this is my Kubernetes and the other stuff in here. Also, there's a Redis here, Bitnami, the Redis. So you can see in here, Kubernetes is in here. You should be able to see everything inside the Visual Studio Code. So let's do some kubectl. I'm going to get pods. Maybe I'm just going to see what is going on inside. So currently, I have run this container, the calculator front end. The calculator front end is this one, just to make sure. The calculator front end is using React. Here it is, using React. So this is the Dapper. You have to install the Dapper first. Okay, it's a one-time process. But if you have to use the ICD, it's better like that. But you can detect whether the Dapper is already there. And then division application. Just consider this one microservice, right? multiplication, and then subtraction. And this is the Redis master slave cache database. So the application is very simple. I'm just going to run this. Look at that, super big calculator. But this is very powerful. For example, if I type 9 divide by, I don't know, like that, for example, this will return 1. But when I do that, if you look at this network, I'm just going to, again, you see this persist, and you can see is this one is actually storing the state, number 1. Number 2 is actually executing the division, okay, divide. That's all. So the application is just like that. So if you see this number 1.69, if I close this app and I reopen the app like that, it will return because the state is there, right? It's something that Dapper, I tell you, you need to prepare everything for the state management inside the Kubernetes. But this one is now it's very easy to maintain. This one. So let's see the service. I'm just going to Control C here. Let's change this to, hold on, X. SPC, which is the service. You can see in here that is running. Yeah. Oh, okay, like that one. So this one is you can see that the calculate is running inside Kubernetes. Then this is the IP that we assign inside as usual. If you go to the Docker file, you should be able to see where you put, sorry, not the Docker file, the deployment. Where you put the IP, okay? Sorry, the port. And then, for example, for the division, also the same. You can see from here. But if you look at the local host, where is the local host? Control C, run again. Here it is. So this is the local host is 55555. This is the one that we set. So yeah, that's it. Okay. So how does this thing work? It's very easy. For example, if I this what should I do? Okay, let's do something like this. I'm just going to let's delete everything. We'll see how fast is this. Okay, and I am going to see is there any port. It is terminating. You can see that it's now is terminating. You actually can, for example, you can kill someone of this, and then it will automatically recreated by the Dapper system. So this one I think is done. Let's try again. Still waiting for this. Okay, now it's gone. So what we can do, for example, I'm just going to kubectl. Just going to apply again, so you can see that when you deploy, this is what happened. You see, that is what happened when you deploy using CI/CD, for example. And once it's deploy, you can watch. Okay. By this time, if you look at the calculator front end still creating, you won't be able to access the application until everything is created. Then should be okay. Okay, I think it's okay now. Yep. So if you go back in here, I'm just going to, let's do it inside private. Okay. You still have this cache, okay, because the Redis cache is not, is still there. The data is still there, so you don't have to worry for this. This is how easy creating application using Dapper. Nothing more, is only running on Dapper. Because I'm a C# developer, I'm just going to show you a little bit before I close this. Is a normal, you see that? It's just a normal API, nothing more than that. There's no, you don't add anything. It's just a normal, like you create a normal API, okay? That is nothing more than that. Yeah, the same. So the magic is because we installed Dapper previously, and then we point that we going to run that inside this one, server.js. So this is the magic. The magic happens in here. For example, this is the calculator. If you want to add, and then just call, this is the Dapper URL. This is the Dapper URL, and then invoke the method, and then this is the Dapper multiply. So you don't access to that service API or port. Just one port, just one. That is the Dapper port. All you have to do, just do like that, and it will relay all the message into the respective API, and will return the value to this. Okay, so what is my time? Okay, I still have 1 minute. Any question?
Hi guys, any question, just type in on the chat window.
Hello, no questions?
Yeah, no questions. I think
Okay.
Thank you so much for Riza. Thanks all for joining. Please submit the feedback for the sessions.
Yes. Thank you,
Thank you
Sentabro.
for making the event a good one. Thank you guys.